Hey, my friend, chances are you are a tech enthusiast or an AI entrepreneur. You want to find out how you can create your file search with vector database outside of the OpenAI system. You want to know what is semantic search, what is vector database, how it works under the hood. Well, my friend, today we're going to dive into Qdrant, a powerful cutting-edge vector database to create your own semantic search application. Now stick around. By the end of this video, you're going to have a fully functional search engine ready to go. So what's the challenge? Well, traditional keyword search methods often fall short when it comes to understanding context and meaning behind the queries. So keyword searches look for exact matches of words or phrases entered by the user. It's quick and easy to use, works well with exact search terms, simple to set up and maintain. So you can think about any RAG application without a vector database that's going to use a keyword search. So if you're building custom GPTs, that's a keyword search. And there's a lot of downsides because it uses up a lot of tokens. If you're going to use the API, you should move away from just using the RAG and start using file search, because it's going to use meaningful search to not only conserve tokens, it also will help you scale. So you can put infinite amount of documents and equip your LM model or your OpenAI assistant with more information, data, etc. Now, this is where semantic search comes in, because it allows us to retrieve more relevant and accurate results by understanding the intent behind the search. For example, the keyword, if you're using just a keyword search or a lexical search, it would return the results because it contains the exact term Darth Vader. It focuses solely on the presence of those specific words. While you're using a semantic search, it would understand that dark force in the galaxy refers to Darth Vader's role as the Sith Lord, and that Luke Skywalker's percentage is directly related to Darth Vader. These are all possible because of semantic search. If you have any kind of data, words, sentences, image, etc., it's going to be converted to vector embeddings, which is essentially converting that data into numerical representations, and that makes it easy to store it in the vector database. And because of these numerical representations, we know how close and far apart these sentences or words or images are, and that is how we can return the most contextually appropriate result for that question or query. Some of the practical applications you can think about is e-commerce and product search. Online retailers use semantic search to understand customer intent and provide more relevant product recommendations. For example, if you want to search for warm clothing for winter, you're going to get jackets, hats, and all that kind of stuff. The search engine understands that these are all warm clothing for winter. If you were to do a keyword search, then you would have to put the exact words like sweater, beanie, etc. So, but how do you implement this? That perhaps create our own vector database from scratch. Don't worry, I'm going to show you. I got you. We're going to solve this today using the Qdrant database. So that's why we're going to use Qdrant. It's high performance vector search at scale. You can also host your data into their Qdrant cloud server. So it starts with 1 gigabyte free cluster, no credit card. It starts with a 1 gigabyte free cluster. So it starts with 1 gigabyte for free cluster, and you can scale as you grow your data sets. And the prices are very competitive, a lot cheaper than storing it in the OpenAI server. So if you're storing data into OpenAI servers, you want to now start thinking about how to quickly move away and start using your own vector database. So this would be a really unique solution for you. You can also use the pricing calculator to estimate how much you are going to be charged. Some of the use cases are advanced search, recommendation system, retrieval augmented generation, data analysis, anomaly detection. In a future video, I'm going to show you how you can create your own recommendation system, which is very easy. So for example, you have users' data and their music preferences, and based on those preferences, the recommendation system can recommend new songs. Okay, the songs could be similar to each other. The user has not discovered yet. This is similar to how Netflix works, and any recommendation system they can think of. It's really easy to set up. Comment below if there's something specific you want to learn with vector database. We can make that happen as well. And don't worry, I'm going to give you the step-by-step, and I'm also going to pull out my handy dandy whiteboard to explain to you what's happening with each step as we're building our own vector database. Qdrant tech documentation, tutorials, search beginners. So we're going to use semantic search one-on-one. So we're going to use semantic search one-on-one. So if you're new to vector database, this is going to be perfect, the semantic search one-on-one, because as we go through the code together, you're going to find out how easy it is to create your own semantic search engine. So by using a vector database, you've now unlocked this amazing feature. All right, so we're going to open up we're going to set up a Google Collaboratory instance. So you go to collabresearch.google.com. You can write your Python code in the cloud. So first and foremost, you need to install a few libraries here, as mentioned. We are installing these two libraries. We're going to be using the sentence transformers to create the embeddings, and we're going to use Qdrant client to interact with our vector database. So you might be wondering, what are embeddings? So I'm going to go to my handy dandy whiteboard right here. Our first step in the process is going to be raw data. Now this could be anything. Could be a music database with songs and their attributes. It could be name, description, and all that kind of stuff. So we have a raw data file. Next step, we need to do some pre-processing, okay? Before we send it off to a text encoder to convert it into a numerical representation, we have to do some pre-processing, make sure the data is clean, there's no errors, and everything's good to go. Next step, we're going to convert that data into text encoding. So it will be numerical representation of the data. As you can see, there's three genres of music. One is rock, hip hop, and classical, okay? This is going to be in the music database. Now, what's happening is the text encoding, which is essentially a machine learning model, converts all the songs into numerical representation and understands what songs are close and far apart to each other. To explain this even further, imagine each of these songs as a numerical representation. It could be 2 dimensions, or it could be more than 2 dimensions. I'm just using 2 dimensions to help explain how the data is stored. Now you can visualize this vector embeddings in a chart. Mozart, Beethoven, and Eminem, Kendrick Lamar. When you visualize these numerical representations in a chart, so as you can see, some of the songs are closer to each other, while some of the songs are far apart from each other. This is how vector database understands what is similar and what is not similar. When you search for a song from the Beatles, it understands that this is a rock song, and it's going to group all the rock songs together similar to each other. Now, if you want to search for hip hop, then it's going to store all the hip hop songs close to this cluster. Okay, if you're a business and you want a consultation how to create your vector database, because it's very important that you get this right, book a consultation call with me. The link is going to be in the description. And as you continue to watch this video, make sure you like, subscribe, and hit that notification bell to get notified every time I drop a new video. So now let's go back to our code. So we downloaded these libraries. Now we need to import these libraries. We're going to import it, copy and import it like that. Next, we need to use the sentence transformer function to specify the machine learning model that we're going to use to convert our data into vector embeddings, which is the numerical representation. So we're going to use encoder, sentence transformer, easy, fast to set up. Now we need to add the dataset. Here they provided you a sample dataset that you can use. These are going to be a list of all the science fiction books in your library. Each book has a metadata, name, author, publication, year, and short description. So the metadata is the attributes that I was talking about. So the more metadata you have, this will help the machine learning model or the encoder model to understand what books are similar or far apart from each other. This metadata helps create the categories, the colors that I just showed you. So we're going to copy this, paste it right here. As you can see, it's a list with dictionary objects in between. Each item in this dictionary, most likely you don't have a data in this format, so you need to convert your data into a format like this. You can use ChatGPT or Claude to help you create this format. These are a collection of dictionaries inside a list object, okay? If you're not familiar with basic Python coding, I have a school coming to you. I have a course that will help you understand the fundamentals of Python, and this will get you started. So in Python, you need to specify the storage location. In this case, we're going to store the data into the local computer. But if you were to store it in Qdrant Cloud, you'd have to set this up in something different. Okay, this is a temporary database. However, it's really easy to set up a cloud database as well. So let's move on to the next step. Create the memory. So all data in Qdrant is stored in collections. So in this case, you're storing books, so we are calling it my books. Now think of collections as a vector store in OpenAI. However, you have a lot more flexibility. So you can create data, you can edit it, and you can also add new data to it, right? So it's very easy and straightforward. So we're going to create our collection. We're going to call it my books. You're going to follow the same structure. Don't worry too much about the attributes that are going here. If you come across any issues, you can always use ChatGPT to help figure out what each of these mean and diagnose where necessary. So we're going to copy this and we're going to paste it. Actually, we're going to remove all these steps. It's actually pretty straightforward. Also, and this next step is actually data upload. So we're just going to create the collection and then upload data to the collection. And the data that goes in is going to be this data set right here. Now comment below if you've used vector database and what are some of the challenges you face and maybe some of the practical applications that you found useful for using vector database. It will be very useful for us to know. Let's examine this code because I think this is the most important piece of the puzzle when you're creating vector database. Now notice the data is formatted like this. Now for every item in the data, you need a unique identifier. Pull out this data later, perhaps remove it, edit it, or something like that. So you need a unique identifier, right? You have a book, and what's happening is when you're uploading data to Qdrant, for each of the book, you have to specify a unique ID. And then you have the vector embeddings that basically tell what the book is about. And we could use all the attributes, description of the book and all that, or the semantic search to understand, okay, so this book is about science fiction. Okay, for example, each item here has different attributes. You have description, author, year, and these all go into creating the vector embeddings, right? So you have the vector, and then you also have a note with all the book's details. It's called a payload. We don't need to worry about this right now. So as you can see, we are creating an ID and we're using the encoder that we specified right here, the encoder, and then we're encoding, meaning that we're converting the attributes into numerical representations. Okay, so we are actually using description field. Okay, this is the field we're going to use to convert to vector embeddings. You can also do some data aikido to convert all this into one column and then specify it right here as well. You can also have the year or author as part of the semantic search feature. Now you're going to have the entire data sets. You can filter the data set as you wish, but to create the vector embeddings or perhaps assign meaning to each of the books, you're going to use the description variable. All right, let's go ahead and run this code. As you can see, it successfully ran. Let's go to the next block. Now we're going to ask the engine a question. So it's very simple when you're asking a question. So you ask the question, it goes to the encoder model, which is the sentence transformer. Then it goes to the vector database, pull out the relevant results. Now, again, what's happening is it's using the same encoder we used to encode the data to pull out that same data as numerical representations. The vector database is going to return all the results. The most relevant is going to be at the top, the least relevant at the bottom. You could specify how many results you want. And also you can use the filter to filter by year or other attributes in the data. Okay, so there is actually a filter condition as well, and this is very useful. And you can imagine yourself using this as well in your own application to filter by specific year or a specific attribute. They can do so with the filter condition. But let's go ahead and ask the engine a question. So in this case, we're going to use the collection. This is the vector store. We're going to use the same encoder that we use to encode our model. We're going to use the same encoder that we use to create the data. And then we're going to search for alien invasion. All right, let's go ahead and run this. As you can see, it's returning the top 3 results. A Martian invasion of Earth throws humans into chaos. Now notice one thing. Nowhere in the description it mentions alien invasion, but the semantic search model was able to understand that this description, they're talking about alien invasion. Now, if you were to use a keyword search, this would obviously fall short, and already you can see how amazing this could be when you're using it in your own applications. Now, let's say if you want to use a limit of 10, so you have more results. You can specify as many results as you want. If you want more training on how to create your assistant from scratch, we have a 3-day challenge for you. Create your assistant, unleash it. We have no code, low code, and full code solutions. We can't wait to see what you're going to create. This is an example how you can narrow down the query by the year, range 2000. If you want more tips on filtering the data, there's different examples that they provide in the documentation. So make sure you take a look at it. There are several ways you can filter the data, and this gives you more flexibility. Let's go run this and see this in action. Let's narrow down the results. As you can see, it narrowed down to all the books after the year 2000. So when you get the results, notice that they all have a similarity score. And this is all done through the machine learning model that we talked about when we create our vector embeddings, they have a distance between each other. So the closer they are to each other, the higher the similarity score is going to be. So when you have a search for alien invasion, the first item is going to be the most similar, and it's at a scale from 0 to 1. Now 0.57 is high enough. It could be higher, but as you can see, the lowest one is 0.17, and you could have certain cases where the instances don't match at all, but it's still going to show up. But you can filter them out by the similarity score. You might want to apply some kind of filtering afterwards to also pull out anything that's greater than 0.3 or 4, just for accuracy and reliability. If you look at the difference between the first and the last result, there's a big difference. And I found the last one pretty funny. A human ambassador is sent to a planet where the inhabitants are genderless and can change gender at will. It's very interesting. Let's try another search. Let's try deadly virus. A deadly virus from outer space threatens to wipe out humanity. Okay, this is an example of a keyword search. We say flu, something like that, and it still pulls up a deadly virus from outer space. So it understands that flu is a virus. So this is pretty powerful when you can understand what's really happening on the back end and how you can enable semantic search for your application. As you can see, the vector database was pretty easy and straightforward to set up. And if you need more guidance on how to do this for your application, make sure you book a call with me. And also, don't forget to join the school community where I post more resources to help you navigate this world of building agents, building assistants, creating vector database to plug into your assistant, creating search capabilities to unleash the full potential of your AI agent. Congratulations, you just created your first vector database using Qdrant. See how easy and simple it was. Now, if you want to use a no-code solution to equip your OpenAI system with a vector database and start using it today, watch this video. Now, if you want more technical details and more examples how the vector database, semantic search, and vector embeddings work, watch this video, and also see how it works using file search with the OpenAI assistant. Alright, so hope you enjoyed this video. Make sure you like, subscribe, hit the notification bell. GPT Pioneers, let's go.